Hello everyone and welcome to another video with me, 320 Sim Pilot. I'm a real-world airline pilot. I currently fly the Boeing 777 aircraft, as you see in front of you here. And in today's video, I'm going to be talking about the handling of this aircraft, the flight controls, and what it is like to fly. This is going to be comparing it to aircraft like the Airbus, as well as sort of conventional aeroplanes like the 737 or even smaller aircraft. What makes the 777 unique? How does it feel to operate? What are some of the traps and gotchas of hand flying this aeroplane? And what has Boeing done to make it stand out from the crowd? You know, why is it different from an Airbus or a conventional aircraft? And it certainly is, make no mistake. It might look like a conventional airplane, and I know Boeing obviously have a reputation for giving the pilot total control, but what does that mean in this jetliner that they made, which is fully fly-by-wire? It's a fly-by-wire aircraft, just like the A320. It has protections for stopping stalls and things like that. It has roll protections. Are they the same as the Airbus, or are they different, and how do they work? Well, today we're going to have a look, and I'm going to give you an essence of what it means to be flying a 777. What does it mean for the pilots, and what is it like? I'll also talk about things like the handling in takeoff, and what the different modes are, especially if we have things like an engine failure. How does the 777 handle that? I'll be flying the 777-300 in Microsoft Flight Simulator 2024, but this does also apply to the 777-200 and the 777-300, all engine variants and in all simulators, of course. This is down to the 777 itself. We'll be using the PMDG because they've done a fantastic job replicating a lot of the different flight control modes that we have in the 777. I hope it's interesting for you, and as ever, not for any real-world use, just to give you some extra context on your home simulations and hopefully give you a better idea of what you're doing when you operate the Boeing 777 in terms of your flight controls and how you're expecting it to behave. After all, you've all paid good money to have this add-on replicated to a high level of detail. PMDG and other developers have put a lot of effort into simulating it, so we want to see, what does it mean? What are we actually engaging with, and is it behaving correctly? Right, let's get started. So let's start by running through the simple parts of a takeoff and the controls of the 777 during a takeoff. I really like taking off the 777. I actually prefer it to taking off in the 787. And part of that comes down to the way the controls are on the ground, but to me it feels very conventional, really. We do have to do the standard things. So when we set our thrust for takeoff, we also put a little bit of forward pressure on the yoke. This is to add some weight to the nose gear so that the nose wheel steering is effective at low speeds. Because of course the rudder at the back of the airplane, this great big rudder here, is not going to be able to do its job until we've got a bit of air flowing over it. So we start off with a bit of forward pressure. You'll also notice, if you ever look outside, the inboard ailerons or flaperons, these panels here just behind the engine, they'll droop. Now, this is not written in the manuals as far as I can tell for any particular serious bit of instruction, but what I think goes on, and what my understanding is from a bit of research, is that they depressurize the hydraulics to these to prevent damage or flutter or something like that. So they droop down, and then as the airplane accelerates, they get lifted up by the airflow, and then they repressurize into the correct position. So you'll see that, and the PMDG does model that accurately. It's the same on the 787 as well. But there we go. So a little bit of forward pressure. Spool up the engines. Depending on your engines will depend how much you need to go. These are GE today with the 777-300 for this one, but this is all true for the 300 and the 200. And then as you roll down the runway, if you've got a strong crosswind, you might need to put a bit of interwind aileron. This is down to just keeping the wings level for the rotation. But we won't talk too much about crosswinds today. We'll just talk about general takeoffs. So there we go. Rudder is conventional, left, right is proportional, and you get full deflection at this speed, and we'll talk more about the rudder once we are in flight, but yeah, the standard rudder as well. The rotation is not anything clever, it's not a rotation law, it's a normal rotation, and then it turns into its in-flight modes once you're up in the air. You can see all this if we go to the flight control tab here, and you'll see all the movements. We do run a flight control check before we get into the air, but we don't actually have to open this screen. Unlike the Airbus, you leave that closed and you have to do it. And you have to do it quite slowly. Boeing says it needs to take a certain amount of time. It's something like 6 seconds, but everyone does it a little more slowly than that. You want to do it nice and carefully. So if you see a Boeing doing its control checks, it's done very calmly. That's because we don't need to look at the screens. The airplane can tell it's checking that the signals are all working correctly. What we're doing is we are moving the yoke, which sends a signal to the primary flight control computers, and those then send the signal to the actual control itself. So we're just checking all of that linkaging is working and the feedback loop is working and so on. Right, so let's get ourselves into the air. So I'll just turn off the parking brake. There we go. Bit of forward pressure. we don't hold it on the brakes on the 777 family, so I can just let it start rolling. Aiming to get to 55% M1, which is just about the 6:30 position on the screen here, something similar to that. And then we're going to press toga. We get thrust ref, and the thrust will drive to its setting, 91.2. It's a very murky day here. We're taking off from Los Angeles International, something we haven't done much on the channel, but it does often get like this. As we get to 80 knots, we can release the pressure on the yoke. The airplane now has enough airflow over the rudder that will be keeping us straight. But generally, it's a heavy airplane. It has a lot of momentum to it. You don't need to fight it much on the ground. It's not like the Airbus. So rolling out down the runway, it's still a bit too sensitive with the ground handling, I think, but there we go. V1, rotate, and now normal rotation. And I like the rotation of the 777 because you can really feel every movement. If you pull back slightly more, you do feel that go straight to the elevator. Positive rates, landing gear coming up. And now you'll see I've got it labelled in here FBW, and I'll talk about that once we're underway. Now we'll keep pitching up. I don't think there's any reason to get to 20 degrees. That's far too high. There we go. Somewhere there. And we are climbing away. Might be a little hard to see, so I'll just zoom in on the PMDG there for you. And now the airplane becomes very stable. All you need to do is do a blip of trim, and it will trim to the target speed. And now we don't need to do anything else. It's in trim. So I let go of the yoke now. I'm doing absolutely nothing, and you can see there it's just holding that pitch. Now I'm going to talk about that trim reference speed because that's such a key thing of flying the 777, so let's get into that. For now, we'll just accelerate and retract the flaps. So here we are, we're sat at 10,000 feet, which is where I'll do most of our demonstrations today. We're just over Los Angeles. Actually, we might need to climb a little bit for the mountains coming up. But yeah, what actually is the 777? Is it a conventional airplane like a 737 or a, even older in the classic sort of Boeing style? Or is it different? Is it a bit like an Airbus? Well, the reality is it is closer to an Airbus, I would say, in some respects. It is a fly-by-wire airplane. So it was Boeing's first, and what that means is the controls not mechanically connected to the flight controls. This yoke here sends signals. What it does is it sends signals to the primary flight control computers, which are up here. Primary flight computers, sorry, there they are. And you can, of course, turn them off if you want to, but that's what generally happens. And today we'll talk mostly about normal flying, what is this like to operate. So the control column sends signals to those computers, and then they send the signal to the actual controls. Now there is an exception to that. There is a mechanical backup available to us. We'll talk about that a little bit later, but the airplane does, of course, have backups if we need it. And it has degraded mode and all sorts, but normal law, that's what happens. So, first of all, what we're going to look at is how it behaves differently from a conventional airplane. So let's turn off the autopilot, I'll turn off the flight directors, and what we'll do is we'll put the flight path vector on so we can see what the airplane's doing. So here we are, flying along, 5 degrees pitch, 250 knots, 10,000 feet, quite a comfortable position. Now, in a conventional airplane, if I add thrust, what will happen is the airplane will pitch up because, of course, we're increasing in airspeed and it's naturally trimmed out for a certain speed. So we're trimmed out for 250 knots here. In a conventional airplane with the engine under the wing like this as well, by adding thrust, it also pushes the nose up. So the airplane will no longer be trimmed for that speed. It will actually sit with the nose high and get slow potentially. So we have to account for that. Likewise, if we suddenly chop the thrust, the nose will drop, not just because it's trying to go back to its airspeed naturally, but also because you've lost thrust that was holding the nose up. So that's all true on the 777, except for the fact that it removes that nose up and down from the engine thrust. As I apply thrust, it counteracts that itself. So I'll show you that. If we go to full thrust now, so I'll go disconnect the auto throttle, I'll just turn that system off entirely. We'll go to full thrust, and you'll see the nose comes up, but nice and gently. And what's going to happen is the nose will come up and the speed will stabilize around about the 250 mark, because that is where the airplane is trimmed for. So it is not concerned about the let me just wind up the altitude to stop it giving us those cautions. It is not concerned about the engine thrust. It is just trying to maintain the speed we've trimmed it for. This is called the trim reference speed. You can't see it in the real aircraft. It's this little blue number here. So as you watch, it will reach that speed and then it will lower the nose again to try and maintain it. And there we go, just as we reach it, it's lowering the nose. It's not perfect, it's not absolutely not perfect, it is still a very natural feel. My point is, it is not the engines that are causing this, it is the actual airspeed only. Likewise, if I chop the thrust with the nose up here, I can bring the thrust right back, and the airplane is rapidly losing speed, so it's going to lower the nose to try and get back to that speed. What will happen is eventually it will stabilize at that speed, or very close to it. Now the reason I can see that speed is because in the PMDG options I have enabled it so I can see it, just to show you for this video. Down it goes. So let's add the thrust in now. We don't want to fly down to those mountains, and the airplane will pitch up and maintain it. I've not done any yoke movement at any point in this. Now of course I'm being specifically bad to the airplane. I'm destabilizing it by adding thrust whilst it's oscillating, but it essentially means it is stable. It will get roughly close to that speed and then sit there. So that's it, trim reference speed. If I want to change it, I can run the trim switches here like normal. So you push them forward and it changes. Now again, you don't have that indication on the flight deck, but let's say I want to fly at 290 knots, I can trim it to there or close to it. And now the airplane will keep lowering the nose because it wants to get back up to that, even though I've got thrust on. So I'm going to need to add a lot of thrust to get the airplane fast enough. And it will then stabilize at that new speed. So essentially, although it's quite a fancy system with this whole trim reference speed, it feels very, very similar. You know, it feels like a conventional aircraft. The airplane will try and climb and try and descend depending on the speed and how you've trimmed it out. You trim it out in the natural sense, go faster and slower, and it all feels very nice. It's very, very nice indeed. Works well. Now there is a neat feature with this trim switch where you can blip the trimmer. If you're near to your speed, if you get the trim close enough, if I just blip it, it just jumps to the speed I'm currently at. So that can be quite handy. So if you want to just get it set where it is, or you can hold it and drag it around. But if you're within a few knots, it will just jump to where you are. A little finicky to demonstrate. There it is. You just saw it jump there. So yeah, that can be pretty handy as well. That works if you're near to the bug speed. But there we go. So, pretty conventional. So if we want to fly level in this airplane, I need to set the correct thrust, power setting, and trim it out for the speed. As you can see here, it's not like an Airbus. This is where it is different. It does need trimming. In the 320 now, I would just put the bird, the FPV, on the horizon like that, and the airplane would just sit there, wouldn't it? It would just do absolutely nothing. But what this airplane is going to do is, what do you think? We're above our trim reference speed. So it's going to have to raise the nose, and it's doing nice and gradually because we're only just creeping away from the speed, but it's going to keep raising that nose and trying to let the speed wash back there. So I need to retrim it for where we are to keep it level. And of course I need to watch out because if my thrust is wrong or changes, then it will keep changing anyway. So it is a much more conventional airplane in this sense. It's not as easy to fly it straight and level as the Airbus. But like I say, it's not as bad as the 737 because if I chop the power, you can see that the power's off, but the nose has not dropped yet. It stays level until the speed starts to wash away, and then it lowers the nose. I hope that's making sense. It's an interesting system, and the 787 uses an almost identical system. Now we're going a bit faster. I don't want to be flying around at this thing, so let's trim it back to 300 knots. Bring the power back. Now, it's a bit misleading for me to show you this trim reference speed all the time. It's not there in the real airplane. I'm going to get rid of it because it's creating me an unnatural way to fly. I'm trying to trim that speed out. And I'm driving the airplane through that, which is just not normal. Here you go, it's in the simulation menu, and you can then show fly-by-wire trim reference speed. So I'm just going to turn it off so that we fly the airplane properly. There we go. So, good. Now, the next thing I want to talk about is bank, of course. We can fly the airplane straight and level. There's a bit more thrust. But what about turning it? Well, the airplane turns also I'd say a little more conventionally. Remember, we're still sending the signal through the primary flight computers, but the airplane will actually bank, or move the ailerons proportionally. So as I move them, it will just do it more, and I can go more, and it goes more, and then it will sit there. The one thing that is different is you don't have to apply a whole load of up trim to maintain your turn up to 30 degrees of bank. That is like the Airbus, but that's not like a conventional aeroplane. So it's sinking here because I'm not actually in trim for the altitude, but there we go. So if I'm flying around and I was in trim, let's set the target speed correctly. Remember, this target speed bug means absolutely nothing when we're not using the automatics. But as I bank around, as I roll out, instead of suddenly being out of trim where it wants to climb, it's climbing a little bit, but it's generally within tolerance. It's within range of being in trim. And that's quite nice. So just like the Airbus, you don't need to apply back pressure, you can just bank and it makes it very nice. I think this is a great feature. It's a thing that's happened a lot with aircraft, airliners, pilots trying to do especially visual maneuvers around tight turns and suddenly picking up high descent rates. Because these are big heavy machines and they lose a lot of lift when you go to larger bank angles. So yeah, very nice. Still takes a little bit, you still got to think about the thrust, you still got to think about the trim, but it doesn't need extra back pressure for those turns. Now, if we bank too far, that stops becoming true. Just like on the Airbus, if we overbank, we do need to apply that back pressure if we want to maintain level. So, like I say, we're actually commanding the ailerons pretty much proportionally. So as you see, if I roll, you can see the roll spoilers come up and that inboard flaperon, that's moving. You'll notice the outboard aileron is not moving. That's because we're going fast enough where it's locked out. So the airplane automatically adjusts the controls that are being used for the speed. So there we go. If I was to slow the airplane right down, of course the speed brakes. And by the way, the trim reference speed, or the normal sort of the way the airplane handles the pitch, means that even the speed brakes don't affect the pitch. It will only be the speed change that does that. But if we slow the airplane right down, I'll trim it back. Eventually, they're still locked out, we're still going too fast. There we go. Now the outboard ailerons, you can see, are moving. There it is. Actually, this might be easy to show you from the cabin. But we can't. If I press C, can we? No, I don't think we can control it. They made it so you can't do that in here, which is such a shame. But anyway, those outboard ailerons, there you go, and we've slowed right down, and now they are moving a lot. Let's get rid of those spoilers. We're probably going a little bit slow here. But at high speed, they are locked out, and the reason is, you can see that there's a bit of wing sort of torsion. You're twisting the wing, and if you're going fast enough, it doesn't need that much control, and these inboard ones are nice and gentle, and they don't put stress on the wing, whereas the outboard ones do. But at low speed, you need more controls because there's less air going over the wing, so we want to have full control over it for our landings and takeoffs, and when we're at low speed, of course. If we accelerate the airplane up, the speed at which has happened is not entirely clear. It's not written down as far as I can tell. It's quite fast because we're still getting aileron here, big airplane, but you can see it's reduced heavily how much it's doing, and then it's locked out, and now we're just on inboard and some cross spoilers. But you see that wing flexing and bending. They are big wings, over 60 meters of wingspan. Another cool feature that the 777 has is wheel to rudder cross tie. Just while we're talking about roll. So what that means is when we're below 210 knots and we're in the normal flight control law, which we are now, and by the way, you can see that if you go to this page, you see at the bottom, it says normal. It's not got any failure or downgrade. If I was to turn off those computers, I get that right. There we go, disconnect. It goes into direct mode. So there you go. It also has a secondary mode as well if there's a failure. So we'll turn it all back on. Right, so wheel to rudder cross tie means that the yoke has a direct link to the rudder. Now at high speeds, it doesn't do anything. But if we get the speed below 210 knots, we're going to need a little bit of flap out to do this. So I just deploy some flap and slow down. So here we go, we're below 210 knots. So now, as I move the yoke, the rudder moves. You don't get feedback for this through the pedals, but if you look down here on the screen, you can see rudder, and as I bank to the right, a little bit of rudder inputs. This, and you can see it outside as well, this is not the fly-by-wire trying to dampen or anything like that. This is not the yaw damper. On the Airbus it does this, but that's because it's trying to coordinate the turn. This is just a mechanical, or not mechanical, but it's a direct linkage that just commands up to 8 degrees of rudder deflection whilst you move the controls. And this is useful if you have large thrust asymmetry on takeoff, such as an engine failure. This is a way to help control the aircraft just using the yoke. Just balances it out a bit. So yeah, you can see that rudder just twitching as I roll the aircraft. And then once you get above 210 knots, that will lock out, so we'll put the nose down. We've got 210 today. And now, oh, still there. There we go. Just saw it lock out there. And now the roll no longer moves the rudder. It is only doing its gust suppression mode now. And you're down. Now I want to talk about the rudder a little more. Let's just turn all these off again. The rudder is more conventional on this aircraft. As I move the rudder pedals, the rudder deflects proportionally. It does not do any fancy fly-by-wire things to it. This is different to the 787. In the 787 there is a much more careful control of the rudder. It's all the autopilot and the flight control computers are always fiddling with it to keep the airplane balanced and trim and so on. But on the 777 it is a very basic rudder. So at high speed, the only thing that happens is there's yaw damping, but we don't actually need to apply rudder ourselves because you're just going fast, and conventional jet aircraft like this don't really need any rudder to coordinate their turns. So what does happen is, as you increase with speed, the maximum rudder deflection that can be commanded reduces. So the pedals will move the same, and crucially they'll feel the same, but as we get faster and faster, so there's full rudder, you can see we're only getting like a third of the rudder control. Let me zoom in on it, it might be a bit smaller screen. So there you go, that's full deflection. And that's because that is sufficient rudder for the aircraft to be fully controllable even with an engine failure, because we're going so fast. If it was to allow us to do full rudder deflection at this speed, then we have the potential to rip the tail off, and that has happened to aircraft. That's 270 knots. So let's bring the throttles right back, raise the nose, and I'm just curious to see, put a bit of flap out, whether we can get the airplane to, I just want to show you that we can get more rudder deflection out of it at lower speeds, because of course this needs to work right down to landing. So let's bring the airplane way back on the speed and have a look. So here we go, we're gear down, flat 15, coming back to flat 15 speed. Now this is a little bit unrealistic because we're a bit high for flat 15, but also we are very heavy. But now you'll see, as I move the pedals, we get almost just over half rudder. So it's increasing the amount it can give us. And that way, we still have full control even in the event of an engine failure. And you'll see the yaw rate isn't much different. But this is just how the airplane sort of protects itself from the rudder. So there is no way to override that system. We won't be able to get ourselves full rudder deflection. It is just giving us what it can. And that's fine. It is a sensible system. And if you go right down to low speed, of course, eventually you'll get full deflection. So let's get the wheels in, some power on. And again, look at that, I'm not trimming or anything. It's all just balancing out the thrust changes, and now it's just going to naturally raise the nose as the speed increases. Beautiful. It's a beautiful machine to fly. Now I said it has some protections. So far we've seen how we trim it out, how the pitch works, which is pretty conventional, how the roll works, and the rudder. So it feels conventional, but it's doing a lot of work for us in the background. It's helping us out. But what does it do if we try and go too far? What if we misinterpret something? Or what if the instruments get something wrong and it's trying to stop us from doing something we actually want to do? How does that work in the 777? Well, you'll be pleased to hear it's as you would expect. It has some protections, but being a Boeing, you can completely override them if you need to. So if I was to go full throttle, and we'll do the overspeed protection first. So for now, I'm accelerating and I'm having to trim forwards on the trim switch, which is just up here. By the way, you can also use these if you run them forward. These directly connect to the trim actuators at the back using cables. So this is why it's the alternate pitch trim system. It's sort of a backup. But if we're trimming forwards, we can't actually trim forward fast enough because we're accelerating so much. So we'll just get the airplane to accelerate. As we go too fast, what the airplane will do is it will stop letting us trim forward, and it will force us to actually hold input. So we can't trim the airplane to fly overspeeding. So here we go, it's overspeeding, and now the nose will naturally start to rise. So I'm not doing anything here. And what I can't do is if I run the trimmers now, you see it's not moving. The airplane will not let me accidentally trim the airplane into an overspeed condition. Now you could run this alternate trimmer and it will still drive the trimmer. Look at that, PMDG have modelled it correctly. It's still driving the trimmer. However, you'll notice the nose is still rising. That's because the primary flight computers are still forcing me to push forward on the yoke. So what Boeing's doing is saying you have to flight the airplane here if you want to carry on in this overspeed. So it's meaning I still can do it if I need to, but the airplane will constantly fight me. It will constantly say, I don't think you should be doing this, but we have total control if we need it. Now this is different from the Airbus that would actually pitch up, and there's only so far you could go before you could no longer do it. But look at this, I can keep pushing forwards. We're getting way too fast here, and I still got enough control to actually keep it there. But I cannot trim. Like I say, using this trim switch, yes, it moves the stabilizer, but the airplane will just reposition the elevators to force me to have to adapt. So there we go. So let's slow down. This is actually very fast. 450 knots is yeah, ridiculous. So I'll put those speed brakes out. I'm surprised if they would even come up at this speed. And there you go. That stabilizer is now way out of trim, so I'm just going to start bringing it back up. And you can see actually I can't even run any trim. I can't even back trim. The trimmer is just frozen. It's just not having it. And you won't be surprised to hear it's actually a very similar story if we get to the low speed. An interesting little thing we'll talk about as we're changing speed so much with that trim is that if I turn off the autopilot again, we're out of trim, is that the trim switches actually command the primary flight control computers to change the trim of the airplane, and then the airplane moves the stabilizer. So this dial here that I keep showing you, I'm showing you that little diamond showing you the stabilizer moving, the trimmer moving up and down in units, but it actually, and you can see here stabilizer stab, but the airplane will actually move the elevators as it needs to and then trim out the stabilizer, which is just like the Airbus as well. So it's you're not directly trimming the stabilizer with this switch. You are, however, with this one. Right, so as we get to low speed, we can expect the airplane to do a very similar thing. It will stop letting us trim in the wrong direction when it's not happy with it, and it would force us to hold back pressure if we want to fight the airplane. So it's going to try and stop us from letting the airplane get into a stall. So there we go, once we go into the yellow band, that's it. It says airspeed low, and now the trimmer just won't run. It's not as intrusive as the Airbus, which is a good or bad thing depending how you look at it. So now I'm sat in this low speed band, I can't trim the airplane anymore, so I'm having to hold back pressure to get it to go any slower. Boeing would say that works because it means that the nose will naturally reduce, because of course if I let go, the nose is having to go down, which is exactly how you get out of a stall. So the airplane is using just basic aerodynamics to get itself out of the stall. If I keep pulling though, I can absolutely override everything and get the airplane into a stall if I really, really, really fight it. Let's get rid of the speed brakes as well, actually, they're not helping. But you can see here, because of where the trim's ended up, it's just not really going there. It is still reducing, and we're getting into a sort of low speed, but just naturally the airplane is going to settle out of it. So it does have a protection that you can fight if you really need to. By the way, if I put bank on, you see we get the stick shaker, which it does have, because if you hit these pitch limit indicators, that is the angle of attack where you will stall. So, or that's where the stick shaker should activate. So if I stick a load of thrust on, we'll probably be able to kick the nose up high enough now. And there you go. We can get right to them, but it's accelerating fast enough to stop it. But that's what those are. We're right at the maximum angle of... There it is. There's the stick shaker. Even though the speed's increased and we're climbing, because I pull through those, we are now in a stall, so we need to get the nose down. But that's what those eyebrows there mean. They have, when you're at high angles of attack or low speed, or you've got flaps out, they'll appear and they show you the maximum you can pitch to before you activate the stick shaker. Now I want to talk about something that's also unique to the 777. We don't have it on the Boeing 787. The 777 has a system called TAC, Thrust Asymmetry Compensation. You might have spotted that switch up here next to the primary flight computer switch. Thrust Asymmetry Compensation. This system is designed to help the pilots in the event of an engine failure. What that means is if there is a loss of thrust on one engine of more than 10% from the other engine, the airplane, or this computer, the Thrust Asymmetry compensation system, will apply rudder to dampen that out. During takeoff on the runway, it only does a bit, so the pilots still need to apply rudder. But if we're in flight, it will fully compensate for that loss of thrust. Now there are some caveats to this, but let me show you how it works first. So here's the rudder position. The rudder trim is at 0, and we can cancel it out with the normal switch there. This is the rudder switch, this trim switch here. So if I was to suddenly have a loss of thrust, let's say the left engine just loses thrust like that, we're more than 10% different, and look at the PFD, look at the yaw, nothing's happened. Well, why is that? Well, if we look down here now, a whole load of rudder trim's been applied. And if we look at our flight controls, you'll see there's a bit of right rudder. Now we're actually going very fast, so we don't need too much rudder. As we were saying earlier, we don't actually have to apply lots and lots of rudder. Oh, let's put it into hold mode. Now, you might be thinking, well, you did it with the autopilot in, so that doesn't count. So let's take out the autopilot, because it doesn't actually have any rudder control at this, unless it's doing its auto land. So I'll take out the autopilot, and look, totally in trim, nothing else for me to do. And if I was to just stick that thrust back on, the engine will come back to life, and as soon as it's within 10% of the other one, thrust asymmetry compensation will stop, and you can see there it is wobbling about a bit, but there we go, it just cuts that to 0. The airplane flies just fine. So let's do it once more with the autopilot out, just to demonstrate. Let's pretend the right engine fails, thrust off, and look at that. No yaw at all. You wouldn't even know it's happened. And we should have a whole load of rudder in. There we go, left rudder. That's twitching because of my pedals are a little bit old now. But there we go. And the airplane will just fly along with the appropriate rudder in. And if I was to reduce the airspeed, obviously, it will apply more rudder. And if I was to increase the amount of asymmetry, so we're idle, if I go a whole load of left thrust, look at that, it's applying more and more. I've got full power on the left engine, more rudder is going in. As I raise the nose, that will get worse. As the airspeed reduces, it will need to hold more and more rudder to keep the airplane stable. So let's just raise the nose right up there, and look at that, you just see it twitching to the left more and more and more as it tries to keep the airplane balanced. So in flight, it fully compensates for the thrust asymmetry. It's a great system. Now here's the catch with it. It only works if the airplane knows how much the engine is producing. So on the 777, if the engine were to lose all data, there's a high chance that the thrust asymmetry system can't work, because if it doesn't know the amount of thrust coming from that engine, then it will simply just not apply the rudder. It would rather not do it than get it wrong. So in that case, the pilots have to apply the rudder themselves. So if I, just to show you what it's like, if I put the thrust back to normal, so we've got both engines running, okay, and we'll turn off thrust asymmetry compensation, and I'll just get it into trim, roughly. And now if I just fail the left engine this time, left engine rolls back, there's absolutely no rudder applied, and you can see that we are just slipping out and out and out, and now the airplane's rolling to the left and it wants us to put right rudder in on the slip. No, it's not too bad, is it? I'm surprised actually. I feel like it would be a little bit worse, but it's mostly noticeable. Of course, the worst position for it to happen is at takeoff. But now you can see that the airplane is got no rudder in at all, and it's just gently trying to roll away, and it needs right rudder. So if I stick in that right rudder manually, it will go back to how it was like with the TAC. And then, of course, you would apply rudder trim yourself using your rudder trim switch here. And then that's all you'd need. If you put in the autopilot and there's no TAC, the autopilot will not do the rudder for you. It's not like the Airbus. The Airbus, once the autopilot's in, it can do the rudder the whole flight. This will only do it when it's auto landing, so when you have land 3. It doesn't engage a rudder channel otherwise, so we are manually controlling that. So if I, with that TAC off, if I were to change the thrust setting, actually got no trim in. So let me stick in a load of trim. There you go, the airplane's out of trim now. Even if I put it into heading selects, it's just going to stay out of trim until I do it myself. You see there, it wants some left rudder. There are some implications of this, the fact that it doesn't do the rudder trim itself. You can genuinely fly airplanes that sit with, especially older airplanes, that sit with a bit of aileron. This is not the same as the 7.8. So they're flying along with zero rudder and there's a little bit of aileron. So then in that case you use the rudder trim, just a tiny bit of rudder trim, and then it will balance out the ailerons. It's a unique feature. You can actually see it in the cruise. You'll see that the yoke is not quite centered. This little line here will be just off to one side, and that's all it takes. And if you do that for a whole flight, you can imagine that adds up to quite an inefficient flight when you have some of those outboard, or sorry, those inboard flaperons slightly deployed. It's just a lot of drag. It's not, the airplane isn't trimmed out properly. So you just have to do a tiny bit of rudder trim just to correct it. Yeah, the 777 is funny like that. The Airbus, of course, you don't, because the Airbus is automatically controlling the rudder, and the 787 is the same, it's automatically controlling the rudder. But there we go. So as a summary of the flight control systems on the 777, we have pitch is controlled conventionally with trim switches, but what they're changing is the trim reference speed. As we move the yoke, it behaves normally, but what it's doing is sending a signal to the primary flight computers that then send it to the control, so it is a fly-by-wire system, and we have to constantly retrim the aircraft to match our current speed that we want it to fly, or to trim it out, just like a normal aircraft. Large thrust changes and speed brake changes and gear changes and flap changes are compensated for by the system, but you'll still need to retrim for the speed. In roll, it's very conventional. You have a proportional rate of roll to your proportional rate of roll to your input, but if you go over 30 degrees, you also have compensation. Sorry, up to 30 degrees, the airplane will apply trim for you, but if you go over that, you're going to need to do it yourself. And you'll also find that if you go too far over 35, the airplane will try and fight its way back. So if I push it way too far, it should drive the bank back to 30 degrees. There it goes, back to 30 degrees. So again, modelled correctly. It's just protecting you from overbanking the aircraft. I don't think I talked about this earlier actually, but there we go. If we go too fast, the airplane will stop letting us trim forwards and force us to hold the yoke in the way. Likewise, if we go too slow, it'll stop letting us trim any slower and force us to hold the yoke up, but we can override it if we need to. The yaw is, although the pedals are the same feeling, they feel more difficult to push at higher angles, but the airplane will limit the amount of rudder deflection you get. So although the pedals move the right amount, the actual control does not move the same, and that's to protect that tail from the large aerodynamic loads it can have. Like you say, it has happened in the past where that tail has managed to be not on the 777, but there was an airliner where that was ripped off from incorrect rudder usage. That's cool. I haven't seen the sphere in Flight Simulator 2024, but I can see it there. There's googly eyes looking at us. The roll system uses the inboard ailerons, or the flaperon, and roll spoilers as it can. And at low speed it will also use the outboard ailerons. We've also seen at low speed, as you apply roll, the rudder will move slightly in the cross tie. That's below 210 knots. There is one final thing which I have talked about in the 777 before when it first released, called the landing attitude modifier. What that does is it means that if we're flying an approach at a slightly higher than normal speed for any reason, it will actually deploy certain speed brakes and ailerons and other lateral controls to make sure that the nose sits in the same position. This is done so that the rad out and everything else is all balanced and it all works like a normal landing. It's a very clever system, even though the airplane's a bit fast, because otherwise the nose might sit a bit too low. I'd also, talking about landings, like to point out something else it does, which is very similar to those of you familiar with the Airbus. What it does is it actually puts a bit of nose down trim just as you go into the flare to make sure the pilot has to pull back on the yoke. The reason they've done this is because with the fly-by-wire system it can naturally neutralise some of those typical effects. So they're just making sure you have to flare like normal. The 777 is probably the nicest landing aircraft I've ever flown in my life, full stop. It lands fantastically. It has excellent gear, but this is a topic for a whole other video. Basically a topic of things I like about the Boeing 777, because there's quite a long list actually. It's a nice plane. In terms of the handling specifically then, we're talking about the normal flying around. What do I think of it? I think it's really nice. The yoke itself is quite light, certainly lighter than the 787. The pitch as well. So hand flying the 777 is quite a treat. It's something you can really enjoy doing. I've had a great time hand flying it, and I sort of look forward to it. You take out the autopilot and you just enjoy it straight away. It's just nice. It also rides turbulence well because it has things like gust suppression and other systems working in the background that we don't have any say over. So if you're flying in the cruise and you're getting turbulence, even if all the yokes things are pretty still, you'll see things moving up here. Although the yoke will actually tilt as you go around the flight, just like a conventional aircraft. But yeah, it's doing all sorts of things with the controls to keep the airplane smooth. So these control laws do work. But by having the main drawbacks of underslung big engines dampened out, so that the pitch power changes where it will move the nose when you change the power setting and destabilize you, things like that. Having that all compensated for, the speed brakes, the bank angle, the flaps, Makes it a really nice machine to operate. It's light on the controls, it's responsive, and it's really enjoyable. And then to top it all off, it lands really nicely. Lovely landing gear, nice approach speeds. So overall, it really is a lovely machine to fly. The 787 by comparison is a heavier machine to fly, I find, and is not quite as pleasant to hand fly for as much time as the 777. I don't know why that is, but that's just my experience of it. These are all just my opinions at the end here, by the way, so this does not reflect anybody else's thoughts, and other pilots will see things differently. So that's all for today's video. Thank you so much for watching. I hope it's been interesting for you. Just my take on the 777 flight controls, and hopefully give you a bit of an extra idea of what it is you're expecting the airplane to do as you fly it around in Microsoft Flight Simulator or your other simulators. There'll be plenty more videos, guides, live streams and tutorials coming on the channel, so do please subscribe if you'd like to see those. Otherwise, thank you so much for watching. We'll see you again in another video or live stream. Bye bye.